So next here, we want to discuss what are called levels of measurement, which is just a classification system for our data and the variables that describe them. The lowest level of measurement is called nominal, and nominal scale data is strictly categories. There's no ordering. Arithmetic operations are not meaningful. It's strictly qualitative data. So things that are in this category would be people's names, for example, colors. There's no ordering there. It's just categories. If you categorize data by color, categorize individuals by gender. Gender is just categories. There's no ordering. And then zip code is also categories. So even though zip code is numerical, the numbers are don't make sense for arithmetic operations, and ordering of the numbers does not make sense. They're strictly categories, geographic categories for where to send the mail. The next level of measurement is what's called ordinal scale, and the keyword in there is order. So these are categories with order, so ordered categories. So intervals between values here are not meaningful. So for example, if you subtract two categories or two data values in two different categories, that doesn't make sense. Examples would be if you rated the top 5 smartphone models. So, first, second, third, fourth, fifth. There is an ordering there, but the second minus first, that doesn't make sense. Any kind of a Likert scale would be ordinal data. And, sizes of, a soft drink or, size of a burger or size of a t-shirt, for example, small, medium, large, that's also ordinal data. The next level is interval scale. So here, your data can be categorized. They can be ordered, so they have the qualities of nominal and ordinal scale, plus differences in the data can be measured. So there are proportionate intervals between your values. However, ratios here are not meaningful. And you don't have a true zero, even if there's a symbol that's called zero. And temperature is a common example here. We could categorize or order objects by their temperature. Differences in degrees, for example, from 5 to 6 degrees is the same as from 10 to 11 degrees. So that 1 degree of difference makes sense here. Whereas up here, the difference from medium to large is not necessarily the same as the difference from small to medium. So those differences don't make sense. However, a temperature of 0 degrees here, that's just an arbitrary starting point. So 0 degrees doesn't mean that the object has no heat. And then also 50 degrees is not twice as hot as 25 degrees. Even though 50 does equal 2 times 25, so even though the temperature is twice, the larger temperature is twice the smaller temperature, it's not measuring the amount of heat in the object per se. Heat is kinetic energy, okay? And temperature is something that's different. The last level of measurement is what's called ratio scale. So this is data that can be categorized, can be ordered, has proportionate intervals, so differences make sense. It also has a true zero, and ratios are meaningful. So this is the highest level of measurement. Weight is an example here. So for example, weights are ordered. A higher value for weight, you can order people by that. So a heavier person has a higher value for weight. The difference from 10 to 20 pounds, that 10-pound difference is the same as the difference from 50 to 60 pounds. Those 10 pounds are the same 10 pounds. A weight of 40 pounds is twice as heavy as a weight of 20 pounds. And then the value 0 is the smallest weight because weight can't be non-negative. So this is a true zero. So that's ratio scale. So we've got 4 levels of measurement and then some examples of each level of measurement.